we're always looking at how we can use filtering for the purposes of doing traffic engineering. Now, what I'm going to do is I'm going to demonstrate how we can continue to use this process using this idea of these tags that we've been inserting, but I want to introduce a new tool that I mentioned previously called a route-tag list. Now, what we're going to do is we're going to step off or start where we left our previous discussion, but I want to come up with or illustrate a second learning scenario. So what I want to do is scenario 2. I want R19's prefixes to be preferred through Cat2 by R22. I want R19 and, so let's see here, how best to do this? Let's do it this way. Let's change that. Let's say 20 I want to be preferred via Cat2, and I want the prefixes from R19 and R21 to be preferred via R4 for our devices on R22, so in the data center. So let's take a look and see what we have right now. So on the data center, I'm going to do a trace route. I'm going to say I want to trace route to 117.16.19.19, and what we're going to find here is that it's going to travel, and I'll go ahead and highlight this on the screen. It's going to travel from R22 to R3. From R3 it's going to go down to Cat2. From Cat2 it's going to R5, and then it's shooting across to R19. Let's repeat this exact same test for R20. 3 to 12 to 5 to 20, which means it's going up to, let's see, I'll pick another color pin here. It's going this way, and then it's going to here. And then lastly, what we're going to do is we're going to find that we are going to follow the same path to reach 21. And we do. So we're going to, oops, didn't mean to do that. We are going to go to R3, to Cat2, to R5, to R21. Now what we're illustrating here is the fact that we're using the same path. Why? Because the metrics are the same and we're picking the best path. Now if I want to be able to change that, I can actually modify how R5 advertises these particular prefixes out. And what I want to use to do that is I want to use this idea of a route-tag list. Now what I'll do is I'm going to go back over to R5. I'm going to try to go back over to R5. And I want to create some values. But first of all, let's annotate what it is we have to work with. We know that R19 is using a 0.0.0.1 tag. We also know that R20 is using 0.0.0.2 as a tag. And we know R21 is using .3, 0.0.0.3 as its tag. Now what I want to do is if I want to have a change in my architecture, I said I wanted the prefixes to R20 to prefer to use Cat2. I wanted these prefixes to use R4. Now the way that I can do this is I can say that if I want to have this one prefer the path to Cat2, let's just advertise what we know from R20 out that interface, which means anything that has the 0.0.0.0.2 tag, I'm going to advertise to Cat2. Now how do I do that? Well, let's take a look at, first of all, being able to identify these prefixes. So how do I identify a tag? Well, I can use something referred to as that route-tag list, and I can give it a name. I'm going to say to Cat2. Now notice I can set up a sequence number. So we'll say sequence 5, for instance. And I'm going to say permit, and then what I can do is I can define the tag that I want to be permitted. So what I want to do is I want to permit this tag right here. So I'm going to say 0.0.0.2, and I'm going to press enter. Well, the problem is it says it's incomplete command. Well, I'm going to use a wildcard mask. And we're going to play with this later. But right now, I'm going to say 0, 0, 0. So I want to match this exactly. So we hit enter, and it's going to take that command. Now what I'm going to do is I'm going to say route-tag list to underscore R4. And I'm going to say sequence 5. And I'm going to say permit 0, 0, 0, 1. Match it exactly. And then what I'm going to do is I'm going to come up here and say match 2 or 3 exactly. And I'm going to make it sequence 10. Do show route-tag list. And now I see my 2 route tag lists. I see 2 cat2 and I see 2 R4. Now what I want to do is I'm going to create a route map, and I'm going to make reference to these because inside the context of a route map in iOS 15 code, I can match on a route-tag list. Here's how we do it. So what I'll do is I'll say route map, and I'm going to say advertise or ADV to cat2. Permit, I'm just going to say 10. And I'm going to say match. And what I'm going to say match tag. And the value that I could see is I could say match on a specific tag. But what I want to do is I want to match on this list. So I'm going to say match the tag or the route tag list that's called 2 cat2. And then I'll just exit out of here. Now what I'm going to do is I'm going to create another route map. I'm going to call this route map advertise to R4. And then what I'm going to say is I'm going to say match tag list to R4. And that's pretty much it. So now all I need to do is I need to go to my routing process, and this is not a named operation. This is going to be a classic EIGRP configuration, and I need to use my distribute list, and I need to be selective as to which interfaces I'm going to advertise prefixes out of. So what I'm going to do here is I'm going to, first of all, show CDP neighbors. And I see I'm connected to R2 via Ethernet 01 and R4, sorry, Cat2 via Ethernet 1 and R4 via 00. So let's go ahead and make these changes. Config T, router, EIGRP 10, and I'm going to say distribute list, and I'm going to say route map, and I'm going to use the advertise to cat2, and I'm going to say I want to use this out of Ethernet 01. We'll say out Ethernet 01. Now all I need to do is come in and say out 00 for advertise to R4. Now what we see here is I've applied this, and we should resync. Notice right now we've resynced. Why? The interface route configuration changed. Now we should also resync on 00, and there it is. So let's look at this. Notice it says interface route configuration changed, interface route configuration changed. This is a resynchronization, which means we're updating our database. Now when I go over here to R22, show IP route 172.16, and let's say 1919 or 19.0, notice my route tag is 1, and now I'm going to use our serial 2/0 interface to reach this destination. 2/0 is going to go to R2, which is ultimately going to lead to Cat1 to Cat4. Now, let's take a look at this. Let's do a trace route now and see how things have changed. So first, let me go ahead and clear what I have right now, and we'll walk through this step by step. And we'll follow it as we go. So first of all, let's do a trace route to 172.16.19.19. And we'll follow it. So I'm going to do it in green. So notice it goes from R22 to R2. From R2 it goes down to Cat1. From Cat1 it goes down to R4. From R4 it goes over to 5. From 5 it shoots up to R19. So did we satisfy the requirement? R19, I want it to prefer R4, which is exactly what it preferred. All right, let's look at another scenario. Let's look at 20. We wanted 20 to prefer Cat 2, which means it's going to have to traverse through R3. So let's do it now. So what we're going to do is we're going to go to R3. From R3, we're going to go down to Cat 2. From Cat 2, we go to R5. From R5, we shoot across to R19, which satisfies the requirement that we traverse Cat 2. And lastly, let's take a look at the final config here for 21.21. And what do we see? We see the fact that we are going to go through R2 again. So I'll do black. So we go to R2. From R2, we go to Cat 1. From Cat 1, we go to R4, all the way to R5, and then shoot straight across to R21. So what we've done is we've illustrated how we can use this for the purposes of traffic engineering. However, keep in mind that we use the distribute list. So if we lose an interface, i.e. we cannot communicate to R3 or any device in the path of R3, we now have a problem, because if we lose the communication to R3, we're not going to be able to use the prefix to reach R20. So distribute list, remember, shuts everything down. It stops how we can be able to do things and the values that we have with regard to high availability and failover. Now, the other scenario here is what if I added another restriction? So what I want to do right now is let's go ahead and erase this. And I want to accomplish the exact same task. I'll go ahead and just write in my dots here. So this is going to be dot 19, dot 20, and dot 21, where everything is going to begin with 172.16.x.x. So it's going to be the router number, where this is R19, 20, and 21. Now, what I want to do is I want to go over here and modify R5, but here's my stipulation. Learning objective 3. I only want a single line route dash tag list. Now right now we have a problem with that. Why? Because we have two specific matches on R5. So let's cut over to R5, exit, exit, show route tag list. And notice I have two entries. I have sequence 10 and sequence 5 and sequence 10. Well, if I wanted to modify this and have it as a single line and get the same outcome, so I would need a single line, which means I'm going to have to leverage my wildcards, my wildcard masks. So let's look at exactly what goes into this. And the easiest and fastest way for me to accomplish this, let me go ahead and erase some of this chicken scratch, is going to be to remove the old list. And we'll create a new one. Config T, no route dash tag list 2 underscore R4. That's going to take it out. Now what I want to do is I'm going to come in here and I'm going to say route dash tag list 2 R4, and we're going to recreate it, but I only want to have a single entry. So let's say sequence 5. And what am I going to do? I'm going to permit, and I'm going to use 0, 0, 0. See, how do I want to do this? Let's see. So I want to permit evens. So I'm going to use 0, 0, 0, and I'm going to say 0, 0, 0, 2, 5, 4. And let's see if that accomplishes the exact same thing. Now, we should resync. Let's wait for that before we do anything else. And I mean, you know, with regard to what we're doing, all we're doing is we're counting our values. So right now, let's look and see here. We've got a resynchronization. Why? Because our interface route configuration changed. So the same thing that we had before. All right, let me take myself out of the equation, and let's do a retest from R22. So the real value that we need to know is if I do a trace route to 172.16.20.20, will it go through Cat 2? And we see that it does. So in this scenario, I'll go ahead and just grab the green. It's going to go to R3. From R3, it's going to Cat 2. From Cat 2 to 5. From Cat 5, it goes all the way up to 20. So that task is satisfied. So the other scenario is will I go through Cat 1 to reach the other prefixes, 19 and 21? Well, I'm not doing anything. So let's kill this. And let's try 20 and 20. I'm sorry, not 20, but 21. Well, that's interesting. I'm not able to reach 20 and 21. Now remember, what we did was this. We took 0.0.0.0 and we said 0, 0, 0, 254, which should have skipped it by 2, so that should have allowed 0, 0, 0 to go through, and it should have allowed 0, 0, 3. But the question is what am I actually filtering through? I'm filtering my odds. I want my odds to be permitted, and I want my evens to be denied. Well, the problem is that if we look here, 2 is even, and I actually want my odds to go through. So if I start counting from 0, so here I've got 0, that's going to count 2, 3, and 4. So that's not what I want to be able to do. Let's go in and take a look at exactly what this output goes through, because what I should have done is I should have started counting from 1. So let's end this. Just trying to highlight some common mistakes, some things that we may do. Let's take a look at this. Let's say show run, let's just say do show route dash map list. Route tag list, sorry. Well, here we have it, but my problem here I think is where we use this value here. So let's go ahead and remove this and we'll re-add it. Go ahead and recreate it. Route tag list 2_R4 sequence 5. It'll automatically insert a sequence in it, but I'm just going to go ahead and add one. And what am I going to do? I'm just going to say 0, 0, 0, 1, 0, 0, 0, 2, 5, 4. Count from 2s based on that. What have I got here? Sequence permit. Now let's see what happens. It should resynchronize. So I made this change right here. I told it to be 0. We do resync. And now let's go back over to R22 and see if we can reach those destinations now. So let's try 1919 first. And what we see here is that now we are traversing through 2 to R1, or Cat 1 to R5 to R4 to R5, and from R5 we're going up to 19. And also what we'll find is that we're going to follow the same path for 21, which is exactly what we wanted to be able to do. So let's grab the black highlighter and we're going to follow it through. It's going up to R2, to Cat 1, to R4, to R5, to R21. So again, we're satisfying all of these concerns, and we're able to do the manipulation using the distribute list using this route dash tag list concept. Now I can have a sequence of permits and denies. I have the capability of being able to look at multiple tags at the same time. This is definitely something that I would highly recommend that you, as students preparing for the CCIE Routing and Switching version 5 exam, spend some time experimenting with, because it's a new capacity and a new capability that exists in the confines of working with 15 code. The route dash tag is not anything to do with named mode. So keep in mind, R5 is just a classic EIGRP configuration. It's just in 15 code. It's going to be a capability and a service that's available to us in order to be able to manipulate how traffic is going to be traversing our infrastructure. But remember, it's used in unison with the distribute list. If we use the distribute list, that means that if we block learning on a particular interface or to a particular process, what ends up happening is that we can in turn not have the high availability in the event that we lose a link in our infrastructure. Also keep in mind that it can be used, since it's in the distribute list, it can be used in unison with the gateway and the prefix list with regard to being able to select what tags we're going to learn or we're going to filter based on our neighbor or based on the particular prefix itself. So play with it, learn it, love it. Put it in your toolbox and use it to pass your exam. I'll see you guys in the next video where we're going to be continuing our conversation about route filtration. All right, I'll see you there. Bye-bye.